Bismillahirrahmanirrahim. I welcome class 10th in my lecture series for chemistry. In our today's lecture, we will discuss certain methods for the preparation of alkanes. There are two general methods for the preparation of alkanes, and those are hydrogenation of alkenes and alkynes, reduction of alkyl halides. So let's discuss the first method, that is the hydrogenation of alkenes and alkynes. What is hydrogenation? Hydrogenation is the addition of hydrogen atoms across the carbon-carbon multiple bonds. These carbon-carbon multiple bonds may be double bond or a triple bond. For example, if you have an alkene, then this bond is a pi bond here. Now, during the process of hydrogenation, this pi bond breaks. When this pi bond breaks, each of the carbon atom is left with an unpaired electron. Now, if we add two hydrogen atoms to this molecule, then each of the hydrogen atom will get attached to each of this carbon atom. And after getting attached, now you may see here that the double bond has been removed and the CC bond is now a single bond. So this means that in the process of hydrogenation, a saturated compound has been produced. So whatever reaction, if there is the addition of hydrogen across the double bond or across the triple bond, then that reaction would be called as the hydrogenation reaction. The reaction conditions, now we will discuss the reaction conditions for the hydrogenation reaction. First, the catalyst that is used during this process may be nickel, or it may be platinum or palladium. The temperature for this process is usually kept at 200 to 300 degrees centigrade if we are using the catalyst nickel. However, if platinum or palladium is used as a catalyst, then this reaction may occur at room temperature. And this reaction usually proceeds at the higher pressure. So these are the reaction conditions for the hydrogenation reactions. In the hydrogenation reactions, the reactants are the alkenes or alkynes, and the product is saturated alkane. This is an example of hydrogenation reaction. Here you may see that ethene is being converted into ethane. Now what happens, that the pi bond between these two carbon atoms first breaks. After the breaking of pi bond, there is the presence of an unpaired electron on each carbon atom. This unpaired electron forms bond with hydrogen atom. This results in the formation of ethane. Now, this hydrogenation process may also occur in alkynes. In alkynes, you may see that there are two pi bonds. Always remember that one pi bond requires one molecule of hydrogen. One pi bond requires one molecule of hydrogen. So since in ethine, which is an alkyne, there are two pi bonds, So it will need two molecules of hydrogen in order to convert into a saturated alkane. So when the hydrogenation of ethane happens, then what happens first, that it got converted into an alkene first. When one of the pi bond in an alkyne breaks and the hydrogen adds across the double bond, then that alkyne gets converted into an alkene first. Now this alkene contains one pi bond. It still contains one pi bond. So then another molecule of hydrogen will be added across that double bond, and it will ultimately get converted into an alkane, that is ethane here. So always remember that hydrogenation of alkynes involve two molecules of hydrogen. Why? Because the alkynes contain two pi bonds. This hydrogenation of alkenes or alkynes is also called as the reduction of alkenes and alkynes. Why called the reduction? Because here the hydrogen atom has been added. So if in any process, if a hydrogen atom is being added, then that process will be called as the reduction. This reaction is also called as addition reaction, because in this reactions one molecule of hydrogen is being added across the double bond. So therefore this reaction can also be called as addition reaction. Let's watch a video related to the hydrogenation of alkenes.
The most important reactions of alkenes are addition reactions. One of the industrially significant examples of addition reaction is the hydrogenation reaction of vegetable oils, which contain unsaturated hydrocarbons having double bonds. In the presence of a nickel catalyst, hydrogen gets added onto the unsaturated hydrocarbons and they are converted into saturated hydrocarbons. This reaction converts vegetable oils into margarine. For simplicity, we will study the hydrogenation reaction with the simplest unsaturated hydrocarbon, which is ethene molecule. This reaction proceeds through 4 different steps. Initially, ethene molecules are adsorbed on the surface of nickel. Adsorption increases the concentration of ethene on the surface of a catalyst, which helps in increasing the rate of the reaction. During adsorption, the double bond between carbon atoms breaks, and new bonds are formed between carbon and the surface of the catalyst. Simultaneously, hydrogen molecules also get adsorbed onto the surface of nickel. Here, they get broken down into hydrogen atoms. These hydrogen atoms can move over the surface of nickel. Of these hydrogen atoms, the one which diffuses close to the original ethene molecule breaks the old bond between carbon and nickel, and a new bond between the carbon atom and hydrogen atom gets formed. The end of the original ethene, where a new bond is formed, now breaks free of the nickel surface, and eventually the other end also breaks free. Thus, the product ethane is now entirely free. And this leaves space on the surface of nickel to adsorb more ethene and hydrogen.
If you look at the first reaction, then the reactant that we have is an alkene. Now, since it is an alkene, so it contains one pi bond. and since there is the presence of one pi bond, so only one molecule of hydrogen will be added across that pi bond. After the addition of hydrogen, this chemical substance will get converted into CH3, CH2, CH3. Now since these two carbon double bond is present between these two carbon atoms, so after the breaking of pi bond, one hydrogen atom will be added to each of these two carbon atoms. When one hydrogen was added, then this CH got converted into CH2 and this CH2 got converted into CH3. So from one propene we got propane during the process of hydrogenation reaction. Now let's discuss the second case. Our second case is an alkyne. It contains two pi bond. So the hydrogenation of alkynes involve the addition of two molecules of hydrogen. So what will happen that since triple bond is present between these two carbon atoms, so two atoms of hydrogen will be added to each of these two carbon atoms. You may also do this reaction like this. First, you may convert it into an alkene, and then in the second step, this alkene will be converted into an alkane. However, if you want to write the end product of this reaction, then you will directly write it as like this, CH3. Since two hydrogen atom is being added to each of these two carbon atoms, so this C will be converted into CH2 and CH will be converted into CH3. Why we use two molecules of hydrogen? Because in this molecule we have two pi bonds. So this was all for the hydrogenation of alkenes and alkynes. Let's discuss the second method, that involves the reduction of alkyl halides. By the reduction of alkyl halides, we can get alkanes. What is reduction? We have read before that reduction involves the addition of hydrogen. So addition of nascent hydrogen in this case is called as the reduction. What is nascent hydrogen? Nascent hydrogen is a newly born atomic hydrogen formed as a result of a chemical reaction. Why we use nascent hydrogen in this reaction? This nascent hydrogen is more reactive than molecular hydrogen. Nascent hydrogen is represented like this, and the molecular hydrogen is represented like this. Here, why it is called as nascent hydrogen? This is an atomic hydrogen that is newly born in a chemical reaction. How this nascent hydrogen is produced? When zinc reacts with HCl, it results in the formation of zinc chloride and two atoms of hydrogen or that are also called as the nascent hydrogen. What actually happens that suppose we have two molecules of HCl here, the bond between H and Cl breaks, and after the breaking of this HCl bond, these two molecules results in the generation of two atomic hydrogens. In addition to the generation of these two atomic hydrogen, there is also the generation of two chlorine atoms. Now these two chlorine atoms reacts with zinc to form ZnCl2, that is the zinc chloride. So this is the process through which we can prepare the nascent hydrogen. In the reduction of alkyl halides, what happens that the halides get substituted with hydrogen atoms. In this process, zinc metal is used and the aqueous solution of HCl or the acetic acid is used. Why the zinc metal and the aqueous solution of HCl or acetic acid is used? Because when zinc reacts with HCl, it results in the generation of nascent hydrogen. And what this nascent hydrogen does, it substitutes, or you may say replace, the halides in an alkyl halide. So in the reduction of alkyl halides, reactants that are used are alkyl halides, and the product that we get at the end of reaction is an alkane. General reaction for the reduction of alkyl halides may be represented like this. Here R represents an alkyl group, X represents a halo group that may be fluorine, chlorine, bromine or iodine. Now if you look at this reaction, you will see that this X group will get replaced by the hydrogen atom. So after this replacement, the alkyl halide got converted into an alkane. For example, let's take an example of an alkyl halide. We take the simplest example, that is the methyl chloride. Now, when the bond between the methyl chloride breaks, then what happens that out of these two, one of the hydrogen atom gets attached to the carbon atom and the another hydrogen atom gets attached to the chlorine atom. So it results in the formation of methane plus HCl. So this is the example for the reduction of an alkyl halides. Let's do a self-assessment exercise related to this reaction. We are given chemical substances like this. In the first case, we have ethyl chloride. Now, you have to write the product for this reaction. A key to write product for these kind of reaction is that you just have to substitute this halide group with hydrogen. So when we will substitute this halide group with hydrogen, then we will get a compound like this. Now take the another example. This is an example of 2-chloropropane. Now since the chlorine atom is present here, so we will replace this chlorine with hydrogen, and at the end we will get propane. Now if you look here, the two nascent atomic hydrogens are being used here. So one of the hydrogen will get attached to this carbon atom and the another hydrogen will react with this chlorine atom to form HCl. So in today's lecture we discussed that how the alkanes are prepared from alkenes and alkynes and from alkyl halides. From alkenes and alkynes we prepared alkanes through the process of hydrogenation. and from alkyl halides we prepared alkanes through the process of reduction. So this was all for today. We will discuss our next topic in our upcoming lecture. Thank you for being with me.